Okay, so today's focus is basically the same thing as 7.2. If you didn't get a chance to do some of the homework questions, today is another opportunity for you to do so. If you remember last class, I did a whole bunch of questions, namely just four questions on just different styles of compound interest where one of those questions you had to find the A value, another question you had to find the P value, another question you had to find the N value, sorry, not the N, the R value, and another where you had to find the T value. If you were able to do simple, I guess algebra and easily rearrange the equation so that you can calculate that easily, then you're basically done for today. What I'm gonna get for you to do is go through some of the textbook questions together, and not only are you going to practice compound interest and oops, and do questions like these four underneath, but I'm also going to try to, I guess, get you to develop an eye for reading the context of the question so that you know which numbers are given and so what letters are given rather and what letters are being asked for. That's my main goal. Okay, so it's actually going to be pretty quick. Kinda, thank you for letting me know. Let me just change your attendance and we'll go from there. Let's see, Kinda is here. Helen and Zane, I'm still waiting on. Okay, so let's take a look at the whiteboard. You do not need to show this anymore. We are going to go through all three. I'm thinking maybe I can try the first two just to get a better idea or just to get you to warm up to these types of questions once again. And then once you're done, maybe we can try well, number nine in this case. Again, I really hope that you're able to just read and just pull out the numbers very easily. Any of these questions that have like a story or something that I can attach to that, and anything that I can make more relevant to you, I'm gonna stop us and sort of let you in on it. Okay? So if you have a piece of paper, please take one out. You may want to just underline today's lesson as just on a title, just write 7.3 present value of a compound interest. And you could put in the brackets and more. Okay? Because sometimes I might ask for the R value, sometimes I might ask for the T value, so on and so forth. Okay, so here it is. I changed some of the numbers just to make it a little more reasonable. Tracy would like to have $100,000 in 4 years to use as a down payment for something. She's considering two different investments. Which is the better choice? So I'm going to copy and paste this question onto a blank slide. I'm going to divide the page in two and try to write down all the information that this question gives us and try to also identify what we're looking for. Okay. And again, I guess the key phrase for today is context is king or context is most important. All right. I hope you can read this. I'm going to make this a little bit bigger. There it is. So, in annotating, I'm hoping you're able to pull out a couple of things. Like for example, I want to have $100,000 in 4 years. If you think about the English behind that, it means that this is going to be my final value. That's how much I want at the end. In other words, my A value is 100,000. And I want this to be done in 4 years. That's my time. She's considering two investments below. The first one, the rate is 0.066 and it's compounded semi-annually. In other words, that's 2 times a year. Hmm? So that's it. So which is the better choice? Can we hash out what that means even? So again, it's one thing to know what numbers to plug in, but what are they asking for? What does it mean to be a better choice? Think about this. Remember, I am trying to I'm trying to collect $100,000 at the end of the year, and I'm trying to grow it. So if the question is, which is the better choice? The better choice is basically whatever lets us grow faster, whichever lets us grow more. So what does it mean to be a better choice then, mathematically speaking? Anyone? Once? No? I'm assuming that people are just shy about it. Better ratio or an oh well, remember, they gave you the ratio already. So I mean if it was better ratio, wouldn't that mean the larger interest is going to be better? Well, that's what we're trying to compare. When it says what is the better choice, an easy way of thinking about it is which one gives us the most interest? Which one is going to give us more money, right? So which one of these two is going to let us grow more money by just letting it sit there? In other words, if I collect the most interest, that means I don't have to start with as large of a number. So this question, when it says which is the better choice, what I'm looking for is which lets me have a smaller principal to start. That would be the better choice. I don't need as much money and I still finish with $100,000. So between these two, I'm looking for the answer that gives us the smaller principal value, right? Again, context is king. Just because the number is big doesn't mean that it's a good thing. So let's put all of this together. The total amount is going to be 100,000, but that is the principal multiplied by 1 plus 0.066 divided by a 2, and that is for 4 years times 2. That's going to be 8. I hope you can see that. Sorry about writing it so slow. And at this point, again, because I showed you how to do the calculations and asked you to practice with the calculator, I'm going to just jump straight ahead and tell you what the principal is. Can you do this with me and see if you get the same answer? I'm going to sound like a broken record, but please practice using your calculator. It's going to make your calculations for this unit so much faster, and you will feel that much more confident. Even if you see a number that you didn't expect, you'll know that you're doing it right. The principal amount that I need to start with is 77,000-ish, and then in 4 years, it will grow to $100,000. It's a pretty sweet deal. Okay, I'm gonna wait for a minute, and if no one raises a question of saying I didn't get it, then I'm gonna assume everyone tried it and everyone understands it, or everyone got the same answer on the calculator, and we're ready for number two. Okay, so it's pretty silent. So the principal is 77. So if I wanted to actually calculate how much interest did I gain from it, you can do that by taking the final amount and subtracting from the initial amount. That should tell you the difference between these two values, which shows me how much I earned for free in that sense. So that would be 100,000 minus 77,125.40, and that equals 22,874.60. In the 4 years, we earned almost $23,000 in interest. Okay. So the next example, the interest rate is smaller, but I am compounding more often. So there's the comparison. I know last class I've just kept on just hammering into you that, regardless of what the rate might be, if you compound it more often, you earn the interest faster and therefore you'll get the money snowballing quicker. Um, so this question is sort of to offset that and to show you that that may not always be the case. So in this case, my rate is smaller. I have $100,000. That is equal to my principal, 1 plus 0.062, but I'm doing it 12 times a year, 4 years times 12. Again, I'm going to assume that you are able to do this in the calculator. Would you do that with me and see if you get the same answer? Okay. Okay. All right. So when you take a look at these two plans, the second plan means that if you use the second plan, you must start with $78,000, which means you, over the 4 years, would only earn just under $22,000 in interest. That's your interest. Whereas plan A, you would earn 23 almost $1,000 in interest. So between these two, which is the better choice for me? Well, clearly it would be option A, the one that is compounded less often but has a larger interest rate. Okay. So last class, I always talked about how compounding it more often is the better deal. Why in this case is it better to choose the higher interest rate? So this is the part where you think beyond just a robot, beyond a calculator, and use a little bit of logic. Why is it better to choose a semi-annual one when I've talked about how compounding more often is gonna make money faster? Think about it, and don't be afraid to be wrong. Take a guess. Nobody? Hmm. Let me explain. Um, oops. Largely, it's because, oh, what the heck is going on here? Oh, it's still annotating. All right. Okay. And eraser. Largely, it's because we only invest for 4 years. Remember, If you are calculating monthly, right, it means it produced that interest a lot sooner, and so it will snowball faster. But the snowballing requires time. The question we did yesterday, it was often in a period of maybe 10 years, 20 years, even 48 years when you, at the age of 17, finally retire, right? So it gives an opportunity for the compounding to actually snowball. But when we're only doing 4 years, semi-annually versus monthly, it makes a very small difference. The biggest difference would come from having a better interest rate. Okay? So between these two, which is a better choice? It'll be that one. All right. Any questions? Okay, let's keep moving. Let's take a look at question number 2. Let's go a little bit faster, shall we? Okay, Jock needs to borrow money to buy dress clothes for his new sales job. Um, there are not too many jobs out there where it forces you to purchase your own uniform per se, but this is a little different in that, you want to look pretty clean and presentable when you're trying to sell something to someone else. So here it is. He estimates that he can repay $1,600 in 6 months. He considers two bank offers. Which should he choose? Now consider, this one's a little different than the one we had before. In the other one, we're like, yay, I want the interest to be high. It makes me happy because the interest goes into my pocket. In this case, we don't want the interest to be high because if the interest is high, we have to pay more, right? So in this case, when I say which should he choose, which is the better choice, we're looking at the one where it costs me less. So let's think about this. I can repay, or Jacques can repay in 6 months. That's my time. So the time is going to be zero point 0.5 years. He estimates that he can repay this much at the end of it all. Does that mean it's the principal, or does that mean it's the future value, the final amount? Going once, going twice. This is the future value or the final amount. This is going to be the end product. So how much can he borrow now if he's going to pay back this much later? That is what we're going to compare. Right? So let me copy and paste this question onto the PowerPoint. And we'll do that. Here we go. And annotating. Okay, my future value, aka the final amount, is going to be 1600. The time in which the interest accumulates is going to be 0.5 years. The rate for A is 0.085, but it's compounded monthly, versus for B, the rate is 0.09, but it's simple interest. So I'm not even going to do this right now. We'll look at that a little bit later. Let's calculate how much interest I would have to pay for A. Ready? Let's see. Future value. The final amount is going to be 1600, and that is equal to principal multiplied by 1 plus 0.085 divided by 12. And I have 0.5 a year, but 12 times a year, so that's going to be 6, which makes sense because the question said it's going to be 6 months. Dot, dot, dot. Please test your calculation skills again. That's right, 5 divided by 12 plus 1 plus 6. You should get 1533.65. So how much the interest did I have to pay? So from here, A minus the P is the same as 1600 is how much I paid the bank. This is how much the bank lent me. It gives me 66.35. The interest that I had to pay the bank was $66.35. Okay? So this is how much they lent me. This is how much I paid back, so that the total amount was 1600. Any questions? No? Okay. Part B is going to be simple interest. What is that? It is not going to follow this geometric sequence question. It is arithmetic sequence. By that I mean sum principal is how much I borrow, and over 1 year, if it was 1 year, so let me take that back. If this is simple interest, remember, I start with T1, which is A, and then T2 is going to be A plus B. What is that B value? It is going to be 9% of my principal, or in this case, 9% of A value. And T2 is going to be 1600. I'm going to actually use this idea right here. A plus an extra 9%, oh, excuse me, not 9%. Half of 9% is going to be 1600. Please remember, the A value, whatever I start with, the D value is only for 6 months. So this would be half of 9%. This would be 0.045 or 4.5% of A. In other words, 1600 is equal to the original 100% plus an extra 4.5%. That represents 660 is equivalent to 104.5%, or sorry, 104.5%. So how much is it equivalent to 100%? Take a look at what I do. I am going to use a ratio to help solve this. Take a look. If 1600 is to 104.5%, then what amount is equivalent to 100%? If you don't like these numbers, you can always do by not the percent, but the actual decimal. 1600 is to 1.045. How much is to 1.00? So you have two ratios or two fractions equaling each other. We can do, what do you call it? Algebra. We can multiply both sides by 1 to get rid of the denominator, but lo and behold, you don't have to divide or multiply by 1 because anything divided by 1 is itself. In essence, what you can say is 1600 divided by 1.045 is x over 1. So x, the 100% that I started off with, is 1600 divided by 1.045. It is 1531.10. This is how much I started with. This is my A value. This is considered the 100%. This is my original principal. So compare. The bank lends me 1531 versus the bank lends me 1533, and by the end of it, I have to pay either bank $1,600. So which one is better? It would be A. Because they give me more money, but I have to pay back the same amount on both sides. So again, everyone, context is king. Okay? I'd like you to give yourself an opportunity to try some on your own. Take a look at number 9. Please read carefully and see what values are given and what they are asking for. Okay, see this. I'm going to erase all of this so it's less of a distraction. 5 years ago, money was invested at 7% per year, compounded annually. Today, the investment is worth $441.28. How much money was originally invested? How much interest was earned? I'm going to give you a minute just to try to pull out what number represents one letter. And once you can do that, the rest is just plugging into a formula. So see if you can do that for me. Okay, have you tried it? Let's take a look. 5 years ago, a certain money was invested. So that tells me the time automatically, right? So that is the R value, compounded annually. Today, the investment is worth $441.28. So today, it's 44128. So you might be tempted to write that as principal because that represents today. But remember, in context, it's 5 years ago. Today is the final amount that I'm talking about, and 5 years ago, a certain amount was invested, right? And that's it. If you are able to understand the context, you would not make a mistake by putting that as P. The final amount is 441.28. What is the original amount? My R is 0.07, my N is 1, and my time, of course, is 5 years ago. The rest is just plugging it in, right? So we have, yeah, Ian, I see that I saw it a little late, sorry. But 44128 equals P 1 plus 0.07 divided by 1, which means I didn't have to do it. 5 years times 1, which means I don't have to write that either. Do the calculations. P should be 314.63. I'll wait a sec for you to catch up and see if that's something that you were able to do. Again, get faster and faster on the calculator. I should have to wait less and less. I should have to wait less and less time for you. Interest. That is going to be the total amount minus the original amount. 441.28 minus 314.63 equals 5, 12, 6, 46, 3, 2, 1. Let me check if I'm wrong. Just did mental. 441.28 minus. Sounds good. Okay. Any questions so far? Okay. If there are any questions, again, I'm going to sort of clear this. There are some questions I'd like you to try on from the textbook. Put this on your sheet somewhere. We've just done numbers 7 to 9. Try number 6, and then number 10 to 14, and then achievement check number 17. Okay, so those are 1, 2, 3, 4, 5, 6, 7 questions. If that's a little too much, do every other. Who cares? I just need you to practice so that you are capable of reading and pulling out information correctly. Of course, priority is in the assignments that I assign to you, but it is what it is. Practice. Okay. Now I'm going to switch gears a little bit and try to make questions that are a little bit more relevant to you so that you see where the how context and how I word the question is very important. Um, hmm, what's important? Someone on chat or someone want to speak up. What is something that you would be willing to buy that you don't have to pay right away? Something that you'd be interested in buying, but there's like a promotion where it's like don't pay until 2023 or something like that. What's something that you might be interested in? Big ticket item. Anyone? Oh, a car. Um, is there a promotion where it says you don't have to pay until, you know what? If you actually go for a decent used car at a used car sales, like sometimes they might actually do that. You don't have to make your first payment until a certain point. Mm, a new computer would work. You know what? Let's do that. Let's pretend there's some budget computer company where they build one for you and you can use the computer for 2 years without paying. And I think that's a good one because we can sort of make it manageable. The numbers aren't that crazy big. Okay? Let's pretend you are interested in a rig, a computer rig that is worth $2,000. That's like, I don't know, a cheap version of Alienware or high-end Asus or whatever. Okay? And you want to buy that in the year 2021. But surprise, there is a promotion where you don't have to pay until 2023. So remember, imagine this is January 1st of 2021. This is January, you have to pay by January 1st of, geez, January 1st of 2023. Okay? So you don't have to pay at all. But the fine print is the interest is 10%. And because you're using the computer every day, the interest is compounded 365 days, 65 times a year. Now, remember, this is 2 years. All right, people, why would they do this promotion? Well, in the beginning, they already make a little bit of money by selling you a computer that's marked up. Okay, so there's profit there. But if you by chance forget, or let's say during that time you lose job, okay? Or budget is tight because, all of a sudden something happened and you have more expenses, etc., etc. There are people who suddenly don't have the means to pay for something they bought a long time ago because they were irresponsible. As soon as it becomes January 2nd, they're like, "Oh, did you just not pay us?" Well, the contract says that all the interest that you built up until now, you must pay. If you pay by January 1st, you only have to pay 2000. But if you forgot and you didn't pay until January 2nd, all the interest is going to have to be added. Yes, but student debt is a little bit more complicated. That you will need to know 7.4 and 7.5 to actually calculate student debt. Okay, so you might be excited, especially if you have older siblings. You're probably interested in how that works out. What does it mean to borrow money from OSAP and whatnot? But you're gonna have to be patient. We can only do a little bit at a time. Okay, so let's figure out how much interest you would have to pay if you were irresponsible. Okay, let's do it. So my present value, my current amount, my principal would be 2000. Okay, my final amount, I do not know. And all the information is here for us. So let's do it. A equals 2000 bracket 1 plus 10% divided by 365. 2 times 365. Someone work that in the calculator for me. I just made this question up, so You might have to confirm my answer with me in case I make a mistake. Okay, I got mine. What did you get? Ian's got, yep, looks good. 2,442.74, right? So take a look. It's 10% for 2 years, so it should be 10% plus 10%. It should be 20%, right? But because they are compounding interest, so their interest is making interest for them, you don't pay an extra $400, you pay 442. You're basically paying 22% interest. So if you're being irresponsible, right? That interest adds up and you don't pay 2000, you end up paying 2442 and 74. Oh my goodness, right? Now I'm going to switch this up a bit. Any questions for this? No? Okay. This is what I mean by context then, everyone. I'm going to change this up. Let us pretend that you actually did pay $2,000. You were very responsible and you did pay your final amount to be $2,000. You paid it, right? Well then, how much, if that's the case, how much did you actually pay today? I know the computer was worth 2000, but you paid 2000 2 years from now. So if we backtrack for 2 years, how much did you actually pay for this computer? You see how context is important? It's the same question. It's the same question, but now that I changed the context, you have to figure out where the numbers go. The context is now this. The amount that I paid is now 2000. It's not the principal. How much is the principal if I paid $2,000 2 years from now? Try that. And again, I'm just making this up, so you might have to confirm with me. I'll wait for somebody. Now I have an answer here. Hoping you're trying this. The principal is that. So if you did pay for a computer, $2,000 for a computer 2 years from now, because of the way they were calculating interest, it's as if you paid 1637 and $51 now with an agreement of 10% per year compounded daily. So that's another way you could think about purchasing and or purchasing a promotion rather. Now I know this is just a computer, but the same can be said about a lot of different things. Like for example, some of you might be really surprised at furniture. So let's say, for example, you grow up, you become a young professional, and you move out into a condo or you rent out a basement somewhere because you want to live in your own place, and finally, you know, leave the nest of the safety of your parents and you want to venture out on your own. And so let's say you want to purchase a couch, right? The brick. You want like the best leather couch for your family room or your living room, whatever, right? And you realize, hmm, save inspiration services account. Really? Is this taking so long? They can't even load the way I want? Okay. So love seats. Okay. So non-leather starts from, $700. Leather look fabric, so I think that's pleather. Okay, it gets to 1,000. If you get real leather, it gets pushes into the two, three, 4,000, and depending on what kind of brand the couch is, it can go as high as five figures, right? Bow genuine leather power reclining sofa, $3,000, and that's for a three-seater. So if your parents or if your family has one of those L-shaped couches, you might want to think about how much that is. If you take a look at some of the um, chairs that you buy, a nice chair can go easily from 200 to $500 a piece. So think about how many chairs are around the dining table. This is the reason why when you were younger, parents, guardians, whoever was always like, don't mess up the couch, don't spill anything, don't eat on the sofa, blah 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 blah, right? Places like the Brick and other, furniture warehouses, these type of places typically have the promotionals of, you know, don't pay until blah blah blah. And so there's a reason behind it because it can be really pricey. Okay. Um, any questions? No? Hmm. How could I make this relevant to you? Hmm. Okay, how about this? How about, so because, yeah, you know what? Clear this stuff. Because of compound interest being as powerful as it is, you know that the more time you keep in there, the more the interest gets to pile up. And as you saw in my previous question with this stuff, right? Not the 6 months, but even the one before, where we had 4 years to save, and it's going to grow semi-annually or compounded monthly. Let's take a look at this 4 years and let's increase it. Let's make it actually worth 48 years. And this is why after all this time I continue to ask yourself like how much are you not going to miss? I'm pretty sure I did this example with you already, but now that you see compound interest, right? Now that you see what's happening, tell me, what is your principal? What is the amount that you are not going to miss? Be honest with yourself and really think about what you're willing to put into an investment and never look at ever again for 48 years. It's worth considering. Okay? That brings us to the end. I don't think I have to do this calculation. I'm pretty sure I've done it with you. I have brain, like baby brain right now, so I really don't remember. But I'm pretty sure I did. Are there any questions regarding compound interest and present value of the compound interest? No. Okay. Here's what we're going to do. Even though I dismiss you, my expectation is that you are in fact doing something for at least the next 25 minutes because we are a little bit early. I am going to be here to take up any questions you might have or any concerns or, questions about the problem set or whatnot. For you, whether you stay in this chat room or stay in this classroom or leave, you are responsible for, number one, finishing off the problem set 6.1 to 6.3 because the deadline is going to be Tuesday. Hard deadline. Okay. Number two, the same day you are going to have the problem set for chapter 6, the chapter 6 unit. Due again, hard deadline Tuesday. And number three, please practice enough of chapter 7.3 so that you don't have to look back. When we get back together on Tuesday afternoon, I am going to finish off chapter 7.4 with you, which will be one of the two bread and butters for your final assignment. And that is when we can really look at math and how it could be even more applicable. Because right now, as amazing as compound interest is, it's still sort of slightly detached from reality for you. It's not realistic for you even after you see the power of compounding. Okay, so do chapter 7.3 homework so you don't have to look back. Okay, so you don't have to review again. All right, last call for questions for the class before you are dismissed, and I will take personal questions. Going once, going twice. Okay, then you are dismissed, and I will stop the recording here. If you have a question about the problem set or you want to discuss something, please remain in chat.